So what that really means, boys and girls, is yes, it may be hard to do challenges, but if you do a little bit every day, you're going to get better at it. So let's have a conversation. In my hand is a blowtorch. Now, I'm going to use this a very dangerous theory today. So repeat after me. I will not try any of this at home. I'm going to fill this tube. I'm going to fill this tube with gas. And I'm going to ignite with that gas. I want you to follow the ball of gas. But follow the ball of gas. Let's try it again. We got to fill it up real good. I'm filling this tube up with gas. I want to ignite it. And we know that when we ignite gas, it should create an explosion. Let's see. Oh, yeah. Let's see if we can get it loud. It's okay. Be safe. Be safe. Be safe. Going louder. Will this force be strong enough? I've never tried this. Let's try and see. Coming up, look at this dash. Yeah? I'm going to make that 2 miles. Honey, I'll be right back and go to Home Depot. Let's see, will the force be strong enough to move that cup? Oh, yeah. Boys and girls, science is all around you. Science is all around you. One thing that I really like and appreciate about the Scouts is that it gives you a chance to be creative and to be innovative. Say innovative. We need more innovators in the world. In my hand, I am holding a paper towel. What am I doing to the paper towel? I'm folding it. What's changing about the paper towel? The shape and the size. Is it possible to reverse those changes and make it look like it did in the beginning? Yeah, there may be a few creases, but it's still a paper towel. Say nothing new. There was nothing new created. This is called a physical change. Physical changes can be reversed. It can be undone. What do you hypothesize? Say hypothesize. A hypothesis is just an educated what? What do you hypothesize would happen if I burn this in fire? How will we know? How will we know? How will we know it's on fire? What will we see? Fire, smoke, and what else? What's that A word? Ash. Now, once I burn that paper towel, I'm creating a new substance. This is a chemical change. And chemical change is great. A chemical change cannot be undone. Chemical change cannot be undone. But guess what? There are some things in science that are really amazing. This paper has been dipped in a special acid. So when you light it, it does this. And it disappears. It disappears. So what I want you to do tonight, I want you to write a story and tell me where does this paper go? It burns instantly without any smoke or ash. Let me try another one. Thank you, Jacob. Give my buddy Jacob a big hand. Jacob likes soccer and playing Fortnite, but that paper has been dipped in a special acid called nitric acid, and it burns instantly without any smoke or ash. Is there any parent in the room with a $20 bill? Awesome. Awesome. Can you come on up, ma'am? Let's give her a big hand. Now, we're going to try to make a solution. Say solution. Now, this morning I went to Chick-fil-A. I had a fruit cup. And a fruit cup is a mixture. Say mixture. A mixture is when you put two or more things together, but you can separate them, right? The apples are still the apples. Thank you. I appreciate it. Just give my kind friend a big hand. I'm gonna need that. She see me sweating a little bit. But a mixture is when you put two or more things together, but you can separate them. We're gonna make a solution. What's your name? Alexa. Let's give Alexa. Alexa. Let's see if she's the real Alexa. Alexa, play Frankie Beverly Maze before I Oh, she's the real Alexa, baby. She's the real Alexa. Alexa, what kind of you is? A 963. 963. Give them a big hand. We're gonna make a solution. Here I have a graduated cylinder. I want you to take, we'll take 70% alcohol. I want you to take this another picture that you pocket though. I want you to measure out 90 milliliters of alcohol. While she's doing that, I'm going to measure out 30 milliliters of water. We're going to combine the two liquids and make a solution. Once we combine them, we can never go back and separate them and remove the alcohol from the water. So get a clear cup right there to your side and pour your alcohol in that cup. I'm going to pour the water in that same cup. I want you to take your $20 bill and put it in the cup. Don't fold it, just, keep it loose and just put it in there. Take those tongs, pick your cup up, pick the tongs up, and come right in the front with us. And we're going to saturate. Say saturate. Saturate. In a few hours, it's going to rain really hard this weekend. And at some point, the ground will become saturated, meaning the water cannot absorb through the soil, and the water will be standing on top of the ground for us to see. We'll see puddles and all that good stuff. We're going to saturate this $20 bill, and we're going to burn it. Whisper to your neighbor. Whisper to your neighbor. What do you think is going to happen? It's illegal to burn money, man, so I hope that I don't get in trouble. You're all right. You're all right. All right. Take it out. Remember, things in science don't always work the way that we think they should. Will the bill burn and turn to char? Or will the bill disappear like the flash paper? Or will something else happen? Hold it out. And we're going to light it in 3. Now, one thing I love about science. One thing I love about science, we make observations with our eyes and with our ears. Let's see what happens. 3, don't let go. 2, and 1. That bill was on fire, but it did not char. Let's give Alexis a big hand. Why do you think that bill did not char? The alcohol. If I would have used just water, nothing would have happened because water is non-flammable. If I would have used only alcohol, that bill would have burned because alcohol is flammable. What you saw burning was the alcohol on top of the water. Say absorb. Absorb. The water absorbed the heat energy and the alcohol burned off until it evaporated. Say evaporated. And now we can still spend that $20 bill. Let's give Alexis a big hand. In my hand, I am holding a plastic jug. What's inside of it? Air. It's air. Take your hand and do this. Say the air is always there. What do you hypothesize would happen if I put alcohol in here and drop a lit match? Whisper to your neighbor. Take your cell phones out because sometimes you might capture something really amazing. Take your cell phones out and let's see if we can capture something. So there's air in here. I just added alcohol. What state of matter is alcohol? I'm going to pour some out. I can smell alcohol. So we also have alcohol vapor, which is what state of matter? Again, what do you think we're going to see? What are we going to see? Fire. What color will the fire be? It has nothing to do with my experiment. I want to set it up for you. It's probably one of my friends over here. So let's get really quiet. Get your phone out. I brought 2 of my containers, so we're going to do it twice. But let that flame build up, and we're going to drop this match inside our container with alcohol and air. In 3, 2, 1. Let's try it again. Let's try it again. And I'm going to tell you what's happening. Now, when I drop the matches, the alcohol vapor, let's go ahead and do all of it. The alcohol vapor and the oxygen, they create a combustion. Say combustion. Combustion. And the air gets forced out of the container. If you notice, this opening is narrow. Whenever there's a great force or pressure coming out of a small opening, the pressure gets increased. So air is getting forced out of the bottle. At the same time, air is being sucked in the bottle, and that's why we heard that whooshing sound. And that whooshing continues until all the alcohol evaporates. Let's get quiet. Let's see if we can make that observation again. 3, 2, and 1. Give me some. Remember, I poured the alcohol out. But if you look at the bottle, you'll see some liquid. Say condensation. Now, when we heated the alcohol, it evaporated. That liquid alcohol turned into a gas. And when air molecules are hot, or when liquids are evaporating, the gases go up. They expand, do like that. And when they get to the top, they cool off. And now you see that condensation in the bottom, and if you look closely, you can even see a cloud. If you're on social media, check out Come With Science.